My name is Lotje Sodderland, and my brain is not normal. At the age of 34, it was permanently damaged by a stroke that almost killed me. It fundamentally changed me and the way I see the world, but also left me fascinated with the pioneers at the cutting edge of the science that saved my life.
I'm going to start making a track into the brain.
This is the first time in the world that people can do mind control.
Amazing. It may still be in its infancy, but neuroscience is advancing quickly into uncharted waters.
But we know so little about how the brain works. We can't explain a single sensation or movement or thought or emotion in any really comprehensive, fundamental way.
And then they said, we're going to do the stimulation on you. And I could just hear all of the feelings. And I never could before.
And pulse again.
So I want to find out if we fully understand the risks of trying to fix a broken brain like mine. Until 5 years ago, I led a busy, exciting life. I worked at an advertising agency as a producer of branded content. I had a really active social life, so I was always with friends and having fun. And I didn't even like sleeping. I found sleeping really wasteful of my time. Then one night, all that changed when I suffered a stroke and nearly died. I went to bed as normal. I just remember waking up with a sort of excruciating pain in my head, but it wasn't a headache, it was a different kind of pain. So I was kind of coming in and out of being conscious. And I remember looking at my phone, and I knew that it could help me, this tool, but I didn't know how it worked. Then I lost consciousness again, and somebody else called 999. Emergency surgery removed about half a cup of blood that had leaked into my brain from a burst vessel. After 2 days in an induced coma, I woke up in a world I didn't recognize. I didn't know where I was, but it wasn't like I didn't know who I was. It was like kind of being disembodied and your body being sort of taken over by a new life.
I'm alive, but I'm not dead.
I had no sense of a past or a future. Yeah, my memory had sort of evaporated. Matilda is my... a nephew? Niece. Today, the damage done to my brain means that my experience of life is intensified. Noises seem louder. Colours seem brighter. My most basic human emotions, like love and fear, are heightened. Although I can write, my ability to read has virtually gone. Diagnosis. Right inferior. My thoughts are faster than my speech. So internally, there's a lot more going on than I'm able to express externally. Thoughts become all swirly and whirly like that. So 5 years on, I have become kind of accustomed to my new life. You know, I don't really expose myself to loud noises. I kind of lead a kind of monastic existence, really quiet. I don't, you know, I spend a lot of time alone. If the damage to my brain has left me such a different person, I want to know, are we fully aware of the impact that manipulating malfunctioning brains like mine can have on the very essence of who we are? I've become very preoccupied with the human brain, how it works, what it does for us, and also if there is a difference between the human mind and the human brain, and how the two interact. To begin my exploration, I want to first understand what damage my own brain suffered after my stroke. Professor Kathy Price is one of Britain's most prominent neuroscientists, specialising in the relationship between strokes and the brain's ability to read and write. You've had a look at my brain scans, haven't you?
I have, yes. Have you seen your brain scans?
I have, yes, many times.
Yes.
Yeah.
These are some slices through the three-dimensional brain image. We call the area of the brain that's damaged the lesioned area, so a lesion. And your lesion is quite complex looking, so it's probably very unique. So we can see these white areas here are where the bleeding must have damaged your brain. And it shows us that you've got damage in the white matter pathways, which connect the visual inputs that are coming in the back of the head. And they connect up to the language areas either this way or this way. And you've got damage to the pathways that are coming up towards the angular gyrus, which is a classic language area, but it's still very rare. Everybody's interested in it because it's so fascinating.
I see things in a very different way, but I actually really like it.
Are you able to describe what it looked like?
Right at the beginning, everything was just so strange. The whole of experience was so heightened.
Yes.
It was just like being sort of reborn in a strange new world.
From what I understand, you initially had difficulty with your writing and then you've learnt over a year or so to get it back.
Suddenly, one day, it was like a spirit had entered my hand and was writing in my old handwriting and was writing what I was thinking. But I was looking at the words and wasn't able to visually recognise what I was writing.
So was it very surprising to you?
It was the best surprise ever.
Yes.
Yeah, it was amazing because the sudden sense of freedom and expression.
Yes.
Being able to express, even though I wasn't able to
read.
It wasn't a two-way conversation.
Yes.
Could it be that there are certain really fundamental aspects of experience that simply can't be measured and quantified in this scientific way?
Absolutely. There's just too much information for us to learn. The brain is so complex. There are many people engaged in finding out tiny little things which tell us enough to be moving forward and to be publishing, hundreds of thousands of new papers and new discoveries. Or despite all of that exciting information, it still doesn't tell us exactly how is it that you're able to speak or how is it that you're able to write.
100 billion neurons, each connected to tens of thousands of others, all firing electric pulses between each other and onto parts of the body. It feels like we've only just scratched the surface of how this incredible organ functions. How can anyone attempt to try to fix malfunctioning parts of the brain without worrying about the risk? I'm hoping to find part of the answer in Bristol, from someone who's trusting the latest advances in neuroscience to fix one of the few parts of the brain that we do know something about. Hi.
Nice to meet you.
Really nice to meet you.
Yeah.
Thanks so much.
Come in.
Thank you. Retired nurse Deirdre Wild was diagnosed with Parkinson's 12 years ago.
Bits of step.
Thank you.
We just go down.
Some of the nerve cells deep
Yeah,
inside
down
her
there
brain that produce a chemical called dopamine are dying. They help control her movements.
This is difficult, isn't it?
I know.
This thing.
Pain. And as a result, her life has been taken over by involuntary body spasms. So what kind of things are the most challenging, sort of day to day?
I don't know, I've often found it really difficult to describe Parkinson's, or at least my particular form of.
Yeah.
But the best way of describing it for me is it's a sort of invasion. My body feels invaded, my mind feels invaded.
I actually had a stroke myself when I was 34. So I think it's partly the sense of self or the identity that you kind of are suddenly confronted with and the loss of it, you know, having survived something like that.
You've survived so well.
Thank you.
You're amazing, yes.
It's all hidden. You can't see inside there. It's a bit of a mess.
Yes, but nevertheless, it's quite an achievement to be able to preserve the real core self. I'm trying to hang on to me. Because that's what it was.
That sounds so cosy, a bakehouse. To try to preserve the person she feels she still is, she's chosen to have radical surgery. It's called deep brain stimulation and means a surgeon drilling into the very centre of her brain. He'll implant electrodes which should override her lack of dopamine and ease her symptoms. The technique has been around for 20 years, but Deirdre's will be a groundbreaking procedure using a computer-guided robot. How do you feel about the middle of your head being drilled into?
I think it's quite frightening, really, if I'm honest. I do think about the risk, but it's still worth it. Because ahead for me, there is really nothing else.
It's the day of Deirdre's groundbreaking surgery to try and rectify the symptoms of her Parkinson's disease. Neurosurgeon Stephen Gill, who pioneered this new technique, has located the parts in her brain that control her movement. These blue bits are called the subthalamic nuclei, and it's here that Stephen plans to implant electrodes. They will regulate the impulsive movements caused by her brain's lack of dopamine. His unique computer system has even created a route map through her brain for his robot to follow. So it's right in the middle?
It's right in the middle of the clockwork. We're going from up here to somewhere down almost between the eyes.
So accuracy is...
Actually, is critically important. I'm going to start making a track into the brain.
I'm struck by how small and helpless Deirdre looks on the operating table, surrounded by tubes and machines. Yet her desire to maintain the essence of who she is so great that she's willing to let someone drill a hole into the centre of her brain.
Okay, bipolar, please.
Is the robot telling you how far in you can go?
Yes, the robot knows all the measurements I need to go to. So it's guiding this very fine probe. I'm going to pass down to the target. So this is going quite a long way in. I'm going to just wiggle its way down so it's dissecting its way. So it should now be just going into that nucleus now.
It's only 5 years ago that my brain was being operated on, so watching Deirdre's surgery isn't easy. As Stephen drills into the very core of her brain, I'm reminded how awe-inspiring this science is. It's like he's diving into her soul to bring back the person she was before.
So this is the electrode. Don't get too close to it. And now I'm just putting down the electrode Going down to the target.
To see surgery and to see drilling and bits coming out and going in. Trust is really fundamental. I mean, but I also think desperation. You wouldn't do something like this unless you had no other option.
So this is the generator.
In 5 weeks' time, Deirdre's electrodes will get switched on, and only then will she know if the stimulation has worked.
Deep brain stimulation doesn't reverse the disease. It overrides many aspects of it and makes people quite functional. Deirdre might be able to reduce the involuntary movements that are such a nuisance for her. And we will find out in a few weeks.
Performing DBS with the robot-to-computer interface is unique to this hospital. It is very, very new, so obviously I hope that the outcome will be a really positive one for her to have made it worthwhile. I know how earth-shattering losing your identity to a malfunctioning brain can be. After my brain hemorrhage 5 years ago, I felt like a very different person. I could write but not read, and was almost incapable of processing even simple information.
We're not sure what's going to happen today. It's either going to be a new place, or something completely different. We're just not sure.
Desperate to reclaim some of the old me, I also agreed to some cutting-edge treatment. I underwent a series of tests using electric pulses to fire up the parts of my brain responsible for reading.
That's a mistake.
But I developed a problem.
So I just saw a flash. Ugh, that's deeply unpleasant. I didn't do that before. This is new.
Strike.
Okay. Strike.
Winner. Run through that block and I'll get Jenny down.
Next one.
Just hold it down.
Sure?
Yeah.
The treatment had to be stopped when I experienced convulsive seizures, leaving me needing medication for the rest of my life. The whole episode was so frightening. I've decided to let my broken brain be. I felt elated to be alive. Also, people kept telling me, you're really lucky to be alive. And somehow that was sinking in, that information was sinking in. The experience has left me wondering if science really knows what it's playing with when trying to fix the parts of our brain that are less tangible, the parts that make us human. To answer this, I've come to America to meet one of the pioneers in her field, Dr. Lindsay Oberman. For the last 10 years, she's been conducting research with people on the autistic spectrum to see if she can unlock our most human of emotions, empathy.
Lindsay. Hi, Lotje. Nice to meet you.
So good to meet you.
Come on back.
Lindsay taught neurology at Harvard University and is considered one of the world's leading experts on autism. Although I'm anxious because her methods remind me of the treatment that I had.
So this device is a transcranial magnetic stimulator. So transcranial literally means just through the head. Magnetic, because it's a magnetic field that's discharged from the machine, and stimulator, because it activates the brain. And what happens is when this pulses, when I press the button that says pulse, a very rapid magnetic field is discharged from the coil, and it's going to activate the part of the brain that this is sitting over.
Can I actually have a glass of water?
Yeah.
Yes.
I'm okay. I felt a bit of a wobble, I get very anxious around these magnetic machines. I felt this kind of sound disappeared, so quite faint. I felt faint, and I wobble like I'm shaking.
Is that because you relate it to what you had, the treatment that you had?
Yeah, I think it's my greatest fear is to have another convulsive seizure. It's an anxiety that I've been trying to overcome. So being around, I'm really interested in learning more about it, but that requires me to be around these machines and this technology.
Yeah, that's fine. She's not right there. Hi. You feeling okay?
Yeah.
Okay.
Sorry, I just felt a bit wobbly for a moment.
No problem. This room gets a little warm too, so let us know, and that's fine. We can take breaks whenever you need to.
Okay.
We're just gonna go right back here.
Today, Lindsay's working with 14-year-old Nathan,
great,
who was diagnosed as being on the autistic spectrum 2 years ago.
Okay.
How are you feeling, Nate?
Go straight
Very
back
good.
into this room here.
I have problems with social interaction. Sometimes when there's a schedule change that can disrupt what I normally would do. Something as simple as sitting in a different seat at dinner can bother me a lot.
So we'll get you comfortable in this chair. All right, so just relax.
As part of her research, Lindsay's testing Nathan's reactions to short magnetic pulses.
And pulse again.
Delivered to the outer layer of the brain, which plays a key role in the basic skills that help us function in society.
You're doing great.
Like being able to interpret what other people are thinking.
And that's it. You doing okay?
Yeah.
Awesome.
I was wondering how that felt, Nathan.
I don't know. My mind was somewhat blank.
Was it?
Yeah.
Was it pleasant, or was it?
It was like traveling to another dimension because it calms you down a lot.
A lot of people say they it's almost like a meditative type of state, that they kind of relax, zone out. That I've heard that from other participants as well.
Wow, thank you for that.
Welcome.
When there's this exciting kind of futuristic idea of manipulating and augmenting your brain, you probably overlook the fact that we're doing something really radical with a really core element of your body.
So we're gonna go head out. And
Lindsay's
thank you
been
so
researching
much.
transcranial magnetic
I'll walk you out
stimulation
here.
on subjects
There
like
you go.
Nathan
You're
for over a
welcome. Thank
decade.
you.
But she's acutely aware that
Thanks.
using a machine to try and switch on human emotion can have its risks.
We've had participants tell us that following the stimulation, they noticed that their processing of emotions were enhanced or different. We've had
So sort of enhanced awareness in a way.
Yes, yeah. We had another woman who had a sort of negative response, thinking about all the things that she may have missed or misinterpreted in her life prior to the stimulation. It makes you think about what are we doing in the brain and what is the consequence on an emotional level, in terms of affecting people's lives and their perceptions of other people following the stimulation.
And there was another volunteer that Lindsay suggested I should meet who embodied her concerns. A man whose response to the stimulation proved life-changing.
It was a world of anger and fear and jealousy, and it just ate me up. Now I realize that my autism really in many ways was a protective shield.
8 years ago, scientists in Boston, exploring the impact of transcranial magnetic stimulation on the brains of people with autism, had what they thought was a eureka moment.
You know, you are the first person to ever come and visit me with gold shoes. That is absolutely a distinctive thing. We have never, ever had that here.
Hope you like them.
Yeah, oh yeah, it's very cool, yeah.
Dr. Lindsay Oberman met John Roberson, the owner of a classic car garage, when he volunteered for her project.
We have Jaguar, we have MG.
After
Bentley,
just one
Rolls-Royce,
session
BMW.
stimulating the area of John's brain that controls empathy and emotion, he experienced an awakening that transformed his life. Beautiful.
Yeah, these are some very pretty and elegant automobiles. These would go very well with your shoes. Absolutely.
In your early life, did you feel that there was an emotional disconnect in the brain?
So that's an important thing. I grew up with autism in the 1960s at a time when autistic people who spoke, as I do, weren't recognized as autistic. Someone like me who can't read your body language or your face, or any social cues from you, you could smile at me, and I couldn't tell if you think I'm sweet and you'd like to get to know me better, or you think I just broke your prize vase and you just are really, really mad, you know? I always had the sense that I was different and less than everyone else. I was a second-class kid, and I grew up to feel like I was a second-class grown-up.
Despite his emotional disconnect, John married and started a family. But throughout his adult life, he always felt there was something missing. Then, age 51, he met Lindsay. So can you describe the TMS? What was it like and what happened?
The clicking stopped, the fan went off, and I realized half an hour had passed. And it was like I was in just a meditative state. And I didn't feel any different. A little disappointed. I felt a little bit like I had a foolish expectation. And I go out and I get in the car and start driving home. And I turned on the music in the car, and it was this band singing a song called You Are the Words. And I could just hear all of the feelings of the singers. And I realized the art of it, you know, that I never could before. And you know, it's been 8 years, and I still feel that. And I can't go to movies anymore because I'm overwhelmed by the emotion. I can't read in a book like a story of a child being hurt or something. And of course, nobody expected that would happen to me. And it really has changed me a lot.
So, are you glad that you did it?
I had this like crazy fantasy that there was this world of beauty and sweetness and light, and if only I could see it, I wouldn't have that disability anymore. And when I could see it, it was a world of anger and fear and jealousy and angst, and it just ate me up. My marriage unraveled, and I got divorced, and I almost killed myself. Now I realize that my autism really in many ways was a protective shield. For me, the experience after those stimulations, it was a very, very rough ride. And yes, I'm more insightful and I can do more things. I can take part in groups. I can talk to people like you with confidence. But it came at a cost.
It blows my mind that just one short session using a magnetic pulse could switch on John's most human emotions and transform the essence of who he is. It just shows how vulnerable and malleable the brain can be to manipulation. After my stroke, some pathways between the billions of neurons in my brain were disrupted. I've come to the Massachusetts Institute of Technology to meet a team who are trying to unlock the mystery of what each of these pathways does. Working with a groundbreaking technique called optogenetics, Ed Boyden is the man leading the project and is tipped to win a Nobel Prize for his work. I wanted to ask you about your work with optogenetics.
Sure.
Could you explain what optogenetics are and how you got into that world and what you're doing with it?
Yeah. We launched optogenetics to control brain circuitry, and in particular, the high-speed electrical pulses that neurons generate when they're computing. So how can you do that? Well, there are lots of ways to try to induce brain activity, magnetic pulses, drugs, but you can't aim magnetism. Drugs are too slow. So what we decided to do was to make neurons sensitive to light, and then you could aim light at them and turn them on or off. And the way we made them sensitive to light was we took molecules from the natural world, basically photosynthetic molecules from bacteria and all sorts of other critters. They convert light into electrical energy. And so we borrowed those from nature, we installed them into the neurons, then shine light on the neuron, those molecules convert the light into an electrical signal, and the electrical signal makes the neuron go. And so then we can dial in information into the brain. We can upload sensations like visual inputs or auditory inputs. You can make the brain more anxious, you can make it more calm. You can also trigger a memory to be recalled, or you can trigger it to be forgotten.
Really?
So you can pinpoint exactly the sites in the brain that drive emotions that are positive versus negative. You can even cause memories to be recalled long after people thought they were forgotten.
What has been the most extreme?
Well, I think this group at Caltech that found a cluster of cells that, when they activated them with light, mice would attack whatever was next to them, even a rubber glove. I thought that was a really stunning study because it suggests that things like violence and aggression could be deconstructed into neural circuits. And so this highlights, I think, how you can start to use these tools to tease apart very, even philosophically challenging, ethically interesting kinds of concepts.
This is a zoomed-in part of the hippocampus.
Oh, wow.
Okay.
So far, Ed's team has only experimented on mice, but he thinks memory manipulation will soon move on to humans. So what's the kind of ultimate potential of optogenetics in terms of what the future might look like?
My hope is that with optogenetics, we can really start to turn on and off all these different brain circuits and precisely understand how they contribute to behaviors. Things like post-traumatic stress disorder, where negative memories really can impair a person's functioning and make them even too terrified to leave their room and go out into the world. And I think that within the next 5 or 10 years, I wouldn't be surprised if some of those enter clinical trials.
You're speaking my language, kind of.
Great.
Thank you. That really, I've got goosebumps. That makes me so excited to hear that. I know it's a long way off, but meeting Ed makes me think that when we finally understand the inner workings of the brain, as well as we understand every other organ, we really could play God. It made me think a lot about my stroke and how that's affected, one kind of major thing is fear. Like I have this problem with kind of deep-rooted fear that I haven't really been able to eradicate, even though I have tried and I have made some progress. But I was thinking, imagine if I could remove that memory that's so deeply embedded and that is causing me some problems, because I kind of get overwhelmed with these panic attacks and things. This felt really exciting and expansive, but also a little bit alarming, because you start to think about the ultimate potential for that. What if it was available to everybody? If you were in combat, you were able to become like a killing machine because you had no moral compass. There's that same potential in this, bleeding edge technology for brain editing. By exploring the possibilities and the risks neuroscience is taking, as it tries to understand more about the human brain, I've met some incredible pioneers. But trying to grapple with the implications of their work is like unraveling the plot of a sci-fi movie. I think my brain hasn't worked this hard since my stroke. You know, if you speak to a neuroscientist, it's like they're talking a different language. They have their own language. Sometimes it feels like you're learning Chinese or something. It's really difficult. I think it's fun that I have a dodgy brain and that my dodgy brain is trying to understand how this incredibly complicated, delicate thing works. I'm witnessing a brave new world of neuroscience that both scares me and fills me with incredible hope about the possibilities for helping people in the future. But I've also seen the huge risks associated with manipulating the inner workings of our brain. One group of pioneering scientists at the University of Minnesota have developed an incredible way to harness the brain's power without any surgery at all. They have built an interface between mind and machine that has the power to transform thousands of lives.
He's going to show to you how he could use a mind to try to control this robotic arm.
Amazing.
So just by thinking about that, so you can see only just a cap, but don't have to put a brain implant, a chip inside the brain.
Yeah.
So in this experimental project, Brad is not using any of his muscle. He's only thinking about that.
Brad is one of Professor He's students who's been working with him for months developing this technology. Wow! Amazing.
So you see this arm is moving and is being controlled by Brad's mental control signal.
This groundbreaking innovation works by reading the electricity produced by the neurons in Brad's brain when he thinks about moving his body. His thoughts are then processed by computer and converted into movement.
Well done. It's a mind control.
That is
technology.
amazing.
Yeah.
So the mind has the same mechanical potential as the body.
That's correct. That's correct.
I'm just imagining somebody who's paralyzed suddenly gaining independence through such a machine. Brad, how do you think it to move? Like, do you think in words?
At the very beginning, when I was learning how to do this, I was imagining purely an action of my own body. Now, after a lot of practice, it's kind of been ingrained to more abstract, right, left, up, down. But you still got to kind of come back to the motor imagination. That's the fundamental of this entire technology. So that's really where the secret is.
You're multitasking here.
Yes.
Very
actually.
impressive.
Yeah, you know, at some point, these actions kind of become ingrained in your mind, and so this is pretty fun, actually.
Is it?
Yeah.
To our knowledge, this is the first time in the world that people can use a non-invasive technology to do mind control, control such a sophisticated task of a robotic arm in a three-dimensional space.
This is amazing, Ben.
Thank you. Yeah, it's very exciting.
It's incredible.
We felt the same way. Actually, we did not report this multitasking, which you saw today. He's talking to you, but he can control a robotic arm to do all the tasks at the same time.
I think it's incredible. This ephemeral thing called the mind is able to physically move this big clunky machine. I started really liking the computer that was able to help, you know, in my imagination, this guy who's lost all his physical abilities. It's a really moving thing, actually. My journey to find out what's possible in the outer reaches of the brain-fixing world has been by turns exhilarating and alarming. If we can choose to add and take away elements of ourselves, Who will we become? It's been 5 weeks since Deirdre's deep brain stimulation, so I've come back to Bristol to see what her future holds.
Oh, I love them.
Today, she'll have the electrodes implanted inside her brain, switched on, in the hope it will relieve her involuntary movements.
Good, how are you?
It's good to see you.
Nice to see
You're
you.
looking really well.
How are you feeling?
Fine.
Yeah?
Yeah, grand. I've no tablets
Peter.
this morning.
How are you?
Good, how are you? So how are you feeling?
Pretty good.
Yeah?
Yeah, I've been a bit tired, but
Yeah.
that's about all. I can honestly say I've had no headaches or pains or anything. I'm a little apprehensive.
Are you?
Yeah, just a bit, but...
Shall we see what happens then?
Yeah.
Okay.
The dyskinesia that you have right now, is that more than normal than before the surgery?
Before the surgery? No, I would have
About
said
the
it was
same.
about the same.
Okay.
Yeah.
Hopefully we can calm this down a little bit.
That would be nice.
See how we go.
Via a wireless link, a current is applied to the electrodes deep inside Deirdre's brain to try and get the neurons firing together.
If you feel anything unusual, let me know. I'm just increasing the current now. And again.
Again, it's almost like I can feel it in this hand now. It's like a buzz.
Okay.
But it's not unpleasant.
Can you give me 10 big finger taps as wide as you can, as quickly as you can? It's really good. Oh, you're gonna surprise me.
Crikey. There you are.
Wow.
And then, incredibly, for the first time in 12 years, Deirdre can walk in a straight line.
Turn better.
That looks better. You've got arm swing. Yeah.
Which it wasn't.
It wasn't. No, you're right.
So that's definitely easier. Yeah.
Good. Fantastic.
That's good.
It just looked like a real kind of sudden calming.
Yes, that's probably a good way of describing it. That's probably how it feels. Exciting.
This is exciting.
Oh.
I think for me, this is a beginning of hopefully getting back some of that control in my life.
Accompanying Deirdre on her journey and witnessing her bravery in the face of this kind of unknown world of brain science has been really moving. The risk she's taken, it's going to give her a new life. Five years ago, I began this exploration of brain and mind with no interest and no experience in, how it all works and how it's put together. So it was kind of an unexpected confrontation with this fundamental organ. Science thinks it understands my brain, but even, the guys at MIT, the holy grail of all things scientific, have the humility to recognize that we know more about black holes than we do about the human brain. I think the greater our understanding of the neural function of how the brain works, it seems that the further we are from understanding the person kind of encased within this structure. I prefer the person that I am now than the person I was before the stroke. Having had my life almost taken away and having a part of my brain taken away has given me humility. So you're always grateful. You're always grateful, you're always happy. So rather than trying to enhance unusual brains, we should be celebrating the fact that each brain is unique.